So he went us around here.
Awesome. Well, thank you guys for all for coming. This is our third event, and we're having a talk by Emeline and Eric on the democratization of space. The NZSSA was set up to inspire students of all ages into space and science. And so we're holding these events to give people a taste about the different parts of science and the sort of the broad spectrum of like everything that you can do there. So won't keep talking. If you guys would like to come up and do your thing. We've got 2 mics set up for both of you. So yeah. Thank you very much.
That's great. Thank you. Yeah. So I'm Eric Dahlstrom, and later on, my wife Emeline Dahlstrom will be talking too. I wanted to give you I have a huge amount of material packed in here, so I'll be skimming through a lot of everything. But it's I wanted to have a few themes. Partly, it's about the importance of student space groups. I'm a big believer in that, and so I think it's really great that you're organized and you're meeting and doing events. And I'll tell you about how it was so important in my career to be involved with student space groups. And then, but also there's so many different aspects of space. Emily will be our efforts here in New Zealand and using space to address problems on Earth, and that's really important. But I'll be talking more about opportunities and the expansion of space of humanity into the solar system, which is you're just at the beginning of, and so you're at a perfect age to be involved in all of this. I sort of represent the I've seen in my life the first space age from the earliest days, and you folks will see in the next space age. Just to prove how ancient I am, I want to show you this. This is a moon globe that my parents gave me when I was a kid, and I just treated it like a ball. I kicked it down the street and added craters to it and everything like that. But only later on did I really appreciate it, because I got this when I was very young, before Apollo, and at this 1964 moon globe had it has the near side of the moon mapped nicely. It has the other side of the moon. Only one image from a Soviet probe had taken one picture on the far side, and there was an unknown region on the moon. And so in my lifetime, we've gone from not knowing what the other side of the moon looks like to probes throughout the solar system and out beyond Pluto. So, and I think that you folks are the right age that you may have a chance to actually go to the moon, personally. We'll talk more about that, but I just want you to realize how quickly things are evolving in space. Even though it looks like it seems often that it's going really slowly, it's actually it's picking up speed right now. So let's see. Let me talk about some of my evolution in my career. So I started in physics and astronomy, went into space engineering. I worked on the design of the space station long ago, and one thing I wanted to point out is that I used to think that everybody sort of who succeeded in these things actually went in a straight line. They got out of school, they got their perfect job, and they went on to a higher job and things like that. It's not true. I mean, actually, everybody I talk to, nobody has gone in a straight line. Everybody has gone into, moved around different jobs. These are some of my different jobs I had. I'm starting to see some of my friends who posting the Twitter things about 5 jobs I used to have. I didn't realize how many famous astronomers used to have jobs in fast food, things like that. So you do whatever it takes to as you move around, and the only thing that's constant is your interest in this long-range future and development of space. So some of the areas I went through, from gravity, black hole physics, and mapping the galaxy, and I stumbled into space engineering, working for NASA on space station, through my student space group connections. So there's one fellow I know from my student space groups, and we've been back and forth where I've worked for him 2 or 3 times, and he's worked for me 2 or 3 times. But anyway, I got involved in space station design, worked at 5 different NASA centers, and then most recently got involved with startup companies in California and in space. But I was one of the first members of the SEDS back in the 1980s. And so this is Todd Hawley and Bob Richards and Peter Diamandis, founders of SEDS. Peter was running SEDS, Todd was his deputy, then Todd was running SEDS, and I was his deputy. This was around the time when Jeff Bezos was running a chapter at SEDS and getting interested in space. Then a few years later, they were the same trio was founders of the International Space University. And that's a long connection of how Emeline and I met and worked together. I'm still in the faculty of ISU. But back waiting for the first space shuttle launch, our student group went down to see the launch, and this is where I met Todd Hawley. So I'm up there baking in the Florida sun in my black shirt. And about 3/4 of the people in this picture ended up in different kinds of space careers for NASA and different private space companies. And we also ended up in a NASA painting. We discovered one time walking down the halls of headquarters and that we saw ourselves in a painting. This is when we discovered that if you're running a student space group and you have a newsletter that reaches like 12 people, you can get a NASA press pass. So we played all the angles and all these things. And here I am with working with Jerry O'Neill on the mass driver to toss things off the moon. So you can see I was a pretty strange looking character. So anyway, Emeline calls, was saying that we'll split it up so that I'll talk about the traditional aerospace careers and Emeline will talk about non-traditional, but there's nothing really traditional about me jumping around at all these crazy different projects. I ended up working with the space station office at NASA Langley, and NASA Langley had a nice role where they were the technical advice to NASA headquarters on space station design. And so all the different centers had, they had 40,000 people working on the design of space station, on the detailed design. We were overseeing the whole design and involving all the redesigns and things like that. And there were 50 engineers that were at NASA Langley specialized in the different subsystems. But they didn't know what to do with me with my physics background, so they let me be a open charter look at any subsystem involved in any aspect of the design. So that was a great position to be in. It was just a little frustrating with the politics of the design system. But for a while, I was the point of contact for the Russian systems before they came into the space station, International Space Station program. So I ended up, one of my preliminary designs was the docking tunnel connecting the U.S. parts to the Russian parts, and so now I feel like like a personal ownership of my little connecting tunnel. If I see it in the movie Gravity, oh, there's my tunnel. Here's the assembly of station here as they're orbiting over New Zealand. I guess we're down here. And so this was the truss being assembled for the solar arrays. And then, so we end up with the, in some sense, space station sort of represents a symbol of what's possible, even though it's way more expensive than it was intended to be. But it still gives you a feeling for what you can imagine building and the complexity of it. This is the how it started with the first connector between the U.S. and the Russian parts with the docking tunnel there, and this is an animation that goes through the assembly sequence, and so it was very interesting to see the different philosophy on the Russian side versus the U.S. side, how they design modules where each module is pretty much independent, and the U.S. ones were completely dependent on having the power system and the other elements available, and how they planned for building up to much higher power system, but it just took years to assemble all the pieces. Keep in mind that every piece that's coming up is basically a shuttle mission delivering something, and the shuttle originally designed to fly for $4 million a piece ended up being $1.6 billion a flight. So that was that you can see the expense of this. It's also funny that the things like we thought we would put up the windows, the cupola very early on to help the assembly, but later on the decision was made to put it up at the very end, and so they were basically doing all this assembly with using just TV cameras on the remote arm and things like that. And also the Japanese module started out as the smallest module, but then everybody else has redesigned and shrunk their module, so the Japanese ended up as the largest one at the end. Yeah, finally the windows have shown up at this point. So it's been basically up and operating all your lives during this assembly, and there's still this is the current configuration with the Expedition 59 up there with and they were going to launch another SpaceX Dragon module tomorrow, but they pushed that back apparently a couple days. Oh, that's the other one. Yeah, that's the Dragon 2 that exploded during testing, which is really disturbing. But yeah, they haven't even released information on what happened with there. But it's interesting to see the changing dynamics also between the U.S. and Russian crews, that sometimes they've been very integrated and eating together, and sometimes they only get together on weekends because it's so big that they say that the crew can spend their entire time without seeing each other. It's like the interior of a couple jumbo aircraft. We also had some failures of imagination here. We used to think that everything will be nice and neat in the interior, and we forgot that if you are running a lab for 20 years, that things can get complicated and messy. They actually have an army of people trying to keep track of where people put equipment, and they've lost things like the size of this table. They accidentally put somewhere and they didn't know what they did with it. Yeah, it's pretty complicated mess. We've been making this timeline for quite a while and updating it, but we have this transition between the sort of traditional big aerospace and then there's all these space companies coming in on the newer new space world with also Emeline will talk about more about the space tourism aspect from the suborbital to orbital and then potentially lunar and Mars. And a lot of this comes down to a big theme of what we're doing, which is the exponential technologies. That the computing technologies have transformed so much that it's made so many things cheaper and better over time. And so computing, tech, AI, robotics, biotech, and so we have things like your phone is 120 million times more powerful than all the computing power of that NASA used for going to for Apollo, and in fact, it's like this phone is 60 times more powerful than a Cray 2 supercomputer from the 1980s, and so it's more powerful than all the computers that the Pentagon had during the Cold War. And your phone, when you turn it on, your phone says you promise not to use it to design nuclear weapons, or Apple gets mad or something. So people have torn apart, the phone components and used them for things like, that's why drones are nice and stable and cheap, is because the gyros and accelerometers are just now $1, $2 chips that are embedded in phones, and our friends who started the company Planet used this they physically launched a phone into space just to see if it would work, and they got it to remotely control it and take pictures and transmit them down, and so they proved that a lot of these components work, and so they could mass produce small satellites at CubeSats, very powerful, using just phone components, things like that. And this is also one of our former students, Peter Platzer of Spire Global. He just launched his 100th satellite, so he's also using these components. Here you can see that like little tiny Planet Labs CubeSats are doing a lot of remote sensing power that some of the big satellites, the $100 million ones, can do. So here's the start of Planet Labs, later Planet. See if you can see where the satellite is in this picture. It's over here on the table. That's their first satellite, and so it's basically like a telescope with chips, and anyway, it has lots of different applications. They actually have you can see that they're now causing a spike in the number of satellites that are being launched each year, and this is when on a Indian launch they launched 88 satellites at once, tossing them out like that. And this is the scheme is that they make a scanning system for the Earth with their CubeSats, so that every day it crosses the around 10:30 in the morning. You have these 200 of these tiny little satellites taking images. Yeah, and also this is where they are also in comparison to some of the big Earth-observing satellites. You just see a swarm of these things. These have a revisit rate of like every 5 days or so. This one, you're guaranteed to go underneath one of their orbits every day. And the same way that this little device, software-defined radio, the chip is now fast enough to keep up with radio frequencies, and so you can program it to become a radio receiver for a wide range of frequencies, and that's the kind that Peter Platzer uses to track ships in the middle of the ocean using these little CubeSats. So, and there's other transformations. I worked on this hyperspectral sensor for Raytheon in 2005. It cost $700 million, and it's the size of this table. And now that sensor fits on a chip. It's still $50,000, but it's a lot better. So that's the kind of thing that it has the power of measuring 100 wavelengths in narrow band at once. So you get a spectrum, a chemical spectrum of the plant, and so you can actually detect things like the biological. You can identify species of plants and health of plants and things like that. Another area that is transformed is some of our other former students created a company Made in Space that has a 3D printer on space station, and they did an early experiment where this astronaut had lost a wrench, and he mentioned it to ground control, and so they decided to surprise him by emailing him a wrench to and printing it. It's one of these things where with the 3D printer, the astronauts never know what they're going to find when they open up the door of the printer, and so it could be a sculpture, it could be a wrench, or it could be lots of other little devices that the space station needs. And right now they have a contract to start building large objects in space out in the vacuum. It's one of their little plastic devices. So there are transformations coming up. Like there's this all these different companies that are trying to do internet from space. Maybe it's hard to say when. 4 years, maybe you'll start to see these constellations. There's about 5 constellations that are coming, and so that could really transform things if you can get 1,000 megabits per second down anywhere in the mountains of New Zealand. Suddenly you could be off grid and still connected. And there's a huge number of companies that are looking at the moon right now, or large scale, or Mars. One that's surprising to me is this United Launch Alliance is a combination of Lockheed and Boeing, pretty traditional, but they think they need 1,000 people out at the moon in 30 years just for propellant stations for their reusable rockets, and because they think there's potential for large-scale solar power collection in space and things like that. And Blue Origin with Jeff Bezos has been focused on the moon for a long time. They keep showing this picture where they're at the pole, the moon, with their lander. They tweeted a cryptic picture of Shackleton's ship yesterday, and waiting for May 9th as some kind of announcement. So we'll see if they have things coming up. And then so Blue Origin has this New Glenn rocket, but they also have a New Armstrong one that they don't show. And then this is a slightly older version of SpaceX's Starship rocket. But in the same way that New Zealand doesn't make the C-17, but it uses the C-17 to support Antarctic operations, I think there's opportunities for New Zealand people to be involved in these big projects, even if you don't make the big rocket. But the whole concept of returning your stage back down and reusing that and dramatically lowering the cost of going to space is really transformative. It is really analogous to, the idea of if you're going to fly a flight from San Francisco to Christchurch, let's not throw away the airplane at the first flight. So let's reuse it. And so Elon Musk thinks that he can change the cost from $160 million down to $7 million of a flight. So that can really make a big difference. And this is not the most recent Falcon Heavy, but this was the first Falcon Heavy launch with the reusing of the boosters. So these it'd be fun to see that up close, because these things are like 20 stories tall landing. So they have the the big boosters, but also have Electron is really getting a lot of notice around the world with from launching from New Zealand to for low cost, quick access, and they're demonstrating some rapid launch of satellites within 2 months, when normally the process is taking 2 years. So someday we'll have to go down there and take a look. I used to be in charge of this lunar lander for Bob Richards. He also plans to launch. He has bought 5 launches from New Zealand to go to the moon. But it's I'm not sure if what he doesn't share his update of his latest plans. I was running a lander when it was this model, then he changed to this, and then he changed to that. But there's a lot of investment in the private world and for space startups these days, and there's a lot more activity than just a few years ago. And so we have, besides Rocket Lab, it's not just rockets. There's all these other areas that are potential activities. You just pick some area that you're interested in and follow it, and and there's. I think the increase in activity is going to help all of our interests here. This is some of the plans for this is historical lunar landings and the Chang'e 4 on the other side of the moon. We're coming up on the 50th anniversary in 3 months of Apollo 11, and we have, but there's about 9 different companies that are trying to land things on the moon, as well as international partners. NASA is, I'm not sure if to believe the recent announcements of trying to send humans to the moon on 2024, but it's going to be a big burst of activity no matter what. And Europe has been working on a moon village concept for a long time. Even Elon Musk is drawing these things, and then just today he just tweeted this picture of updated with his updated vehicle. Also notice that the Earth is this was at a lower latitude, and then this is towards the pole. Because everybody's looking at this high latitude, high polar regions of the moon. This was just somebody's concept of what the interior of one of these things might look like. Elon basically hasn't shared anything on what the interior looks like. There's a lot of interest in going to the moon because of the combination of different resources. And basically nice, different kinds of metals and silicon and oxygen and aluminum, things like that, but also this confirmation that there's water ice at the poles in these craters that have been shadowed for 2 billion years. And so there's about 1 billion tons of water, which is sort of like Littleton Harbor or something like that worth of water. And there's this one crater, Shackleton, which has the rim of the South Pole is on the rim of the crater there. It's about 20 kilometers across. And so this is suddenly be a very exclusive, high value real estate in the solar system. It's it used to be people used to talk about the moon. Oh well, it's about the same everywhere. It doesn't matter where you land and things like that for resources. But it turns out because this part on the rim, it stays in sunlight about 95% of the time because the sun just moves around the edges. But down here, this has not seen the sun for 2 billion years. And so you have all this water ice and volatiles trapped down in the crater, and you have a great spot which is moderate temperatures for being for a base, and that's where. So this is the shadows moving around for a period of a month around Shackleton Crater, and this is an early diagram of where NASA wanted to have a moon base. Unfortunately, it's the same location as the Chinese want to go, the Russians, uh, SpaceX, Blue Origin, everybody is looking at the same spot, which is about 5 kilometers by 1 kilometer. So this will be something really interesting to watch in the next few years. It also happens to be rather nice temperatures up there in comparison to the extremes on the down on the equator or at night. Except for right in the crater, it's at 40 Kelvin, so minus 230 centigrade. So it's about as extreme an environment for robots, even as you can imagine. And maybe I will skip through all the reasons why. I mean, Lockheed and Boeing are actually building this vehicle that will use lunar propellant to move around the inner solar system, and so they think that it's pretty much a sure thing to go out to the moon. And one area that I'm always interested in is the gravity field of the cislunar environment. You basically have these stability points, the Lagrange vibration points that you can put vehicles at, and or like right now there's a Chinese communication relay satellite out at L2, and then in the long range, for example, Patrick Collins, who was advocating space tourism, was saying that he was expecting if you get the price down enough, you can get 5 million passengers a year into space, in lunar hotels and things like that. And so, and Bigelow has basically 6 hotels built and waiting to launch. They're waiting for the commercial crew vehicles, these vehicles to fly next year, or at least Dragon 2 and Starliner, if they can figure out what caused the explosion in Dragon 2 testing. And here's Elon's big Mars plans, once again with his previous version of his vehicle and now his new version of his vehicle he tweeted today. But I'm interested in Mars, but I'm not a big Mars advocate. So it's an interesting thing, but I'm with Jerry O'Neill's space habitats kind of perspective. I don't think there's a reason to go back down into another gravity well unless you want to explore, and so we'll see. But I'm a big fan of asteroids. Back when I started studying near-Earth asteroids, we knew about 12 of them, and today we know about 20,108. We just passed 20,000 on Friday, and already we're up to 108 since then. And so, 167 were discovered this month. These are always being monitored for, is there a potential for one to impact the Earth? And none of these are, plotted out for 100 years, none of these will hit the Earth. And because of solar effects and other things, you can't predict exactly beyond that time frame. But it's still they're still acknowledged that there's incomplete surveys. So we're still finding these things constantly. And New Zealand plays a big role in the detection of these things because the robot telescopes in California and Hawaii and Arizona detect a movement in the sky and then pass it over, and this kindly little couple that we met goes up to the observatory in New Zealand and confirms the orbit, and they've found a whole bunch of these things. And just to give you an idea, these are some of the asteroids that's a real color of the darkness of one of the near-Earth objects. And this is one example down here of Tutatis. And here's Tutatis visiting Christchurch, and so so there's a huge amount of material in these things, and enough to build cities, structures, and things like that. And so I think that's something that you might have a chance to see and participate in. So I think it's happening really fast in this area. And I'll just skip through that some complicated area ideas of mining these things, and also just that the history of the settlement of the Pacific and the settlement of New Zealand, I think, is a great analogy for settlement of space. And so that's part of the reason why I think New Zealand is ideal for this, for the people and the attitude to be ready for actual space settlement. So that was a long presentation, I'm sorry. But, so let me switch over to Emeline's presentation.
Do you have any questions for him?
Yeah.
My question was just regarding, because as you said, it's getting easier and easier to put things up into space, even with private organizations and individuals or groups of individuals. Do you think it poses a threat to the space debris problem? Because it's not like a linear, it's not a linear problem, because once the collisions kickstart, everything just goes into kind of linear. Because
There's
which group is controlling or keeping track of everything? Because this is an international.
The question about space debris, and yes, it is a big issue. And right now, for example, there's about 500 objects, operating satellites in low Earth orbit, and about 20,000 space debris objects, which are about bigger than 10 centimeters. And currently in the U.S., the FCC has approved 13,000 satellites to be added. So it's a factor of 26 increase in satellites. And the big worry is the Kessler Syndrome, which is exponential increase, chain reaction, where two colliding satellites then cause debris that then collided with other satellites, things like that. And so there are things about there are various UN guidelines. There's various launchers that have guidelines, but also one thing I think we need to do is there are a few bad actors that are, not venting their upper stages and allowing the upper stage to explode, and we need to highlight those, because in being interested in this for 15 or 20 years, I've only seen one time where somebody listed who the bad actors were, and it's sort of like, if somebody keeps doing the wrong thing in polluting space, we need to call them out on it. And change their behavior. The standard UN guideline is everything in low Earth orbit has to come down within 25 years. There is a move both with Rocket Lab and even SpaceX to go for lower altitude, and almost because the technology changes on the satellite so quickly, almost to create like a fountain effect of launch a satellite that then only stays in orbit for 2 years before re-entering, and then replace it with a newer technology one. And because when they re-enter, they do re-enter, 95% of them re-enter very cleanly, burning up completely. It's only a few of them that have some tanks that actually survive and drop down to the ground. It's definitely something to worry about, and especially with these giant mega constellations that are being proposed. And then just last week, two geosatellites failed and started drifting and causing a problem in geo. So, it's definitely something to worry about. Yeah.
Just one other question, from that, is there any effective way to clean up satellites?
Oh yeah, active debris removal. There's about 10 ways that have been studied, and a lot of it comes down to cost effectiveness. It's like because it almost costs, like $20 or $50 million to chase down one bit of debris. And so what you want is something that can take down a lot, or at least take down the big pieces that are really potentially hazardous. And so the European Space Agency and with the NVSat, which is a school bus-sized satellite that died, they have a bounty on that for people to, they'll pay people to bring it down. But for the most part, nobody has figured out a really cost-effective way to get large amounts of debris. It's almost like chasing it down with individually with little satellites. Yeah.
This is a question for either or both of you. Do you have a kind of favourite or a method of spacecraft propulsion that you're most excited about, whether it be theoretical or tried and true?
Yeah. There's, one way that people measure the effectiveness of space propulsion is the specific impulse, ISP. And there's one that I'm hopeful to see the results of, which is the Vasimir engine. Variable specific impulse, microwave, something, amplifier, whatever. But it's the problem is that it only is the propulsion side. You need a big energy source. And so if you have a great energy source and then pump it into Vasimir, Vasimir can heat up hydrogen with microwaves and blow it out the back. And it can go everything from high thrust that could take off from a planet to low thrust that can continuously accelerate for months. And so it's a great way for, but you need the energy. And so on the energy side, I'm a big fan for inertial or the some of the fusion systems that are they're not plasma related, but are actually electrostatic fusion, which is I don't know if you know about Farnsworth. Farnsworth was one of the inventors of television, and he not only invented television, he also invented a fusion system, which is because he realized that the inside an old cathode ray tube, like old style television, that you're accelerating particles enough with enough energy that you could actually, if you slam them together, they fuse and give energy out. And so he created a system where he just had rings of charged devices that you slam particles together and make the fusion not using random energy, but just directed energy like that. And so there have been a couple companies that are developing that, and they were funded by the Navy, and they went dark just when they seemed to have good results. And so I'm still waiting for them to pop out and say, because it looked like they were going to have a 30 gigawatt reactor that fits between here and the wall. And if you put it in a 747 with a Vasimir engine, you could fly round trip to the moon without with the fuel you carry on board. So anyway, that's one possibility.
Yeah, and it's very similar. So for me, like right now, because we haven't really changed propulsion from like 50 to 60 years, and
You should talk in from this microphone.
And most of the problem essentially is that today the reason why space is expensive is because you are basically launching mass up there, including your propellant. So if there's anything at all, any new propulsion mechanism that does not have to carry that propulsion, like microwave beaming, for example, which there's another startup company that one of our students kind of like started also, almost a decade ago now, and he also ran out of funding, which would have been like really revolutionary if it actually happened. So those kinds of things would be great. So this is like the second part of the presentation, and as Eric was like saying, I actually think that even so with all of the stuff that he's done, he's still more of the traditional way of kind of like going about a space career where you come from a technical side. Not that I don't have a technical background, I do, but it's just that there's other ways to essentially be part of the space industry, even if you're kind of like not hardcore, basically physics or engineering. And then also as part of my presentation as well, I'll talk about kind of why we're here in New Zealand and what we're trying to do, and maybe how you could also help. So just a little bit of a background again. So I'm Filipino and American. So I still have a Filipino passport, and I basically was born in the Philippines, and I lived there for half my life, essentially. And it was during the time of really the Apollo era. So again, dating myself was pretty old. This picture is Buzz. This was taken like just a few days before I was born, and was his first spacewalk during the Gemini kind of like program. And unfortunately, I was still too young to really remember the moon landing, which I guess Eric does. But that's kind of like, I think, one of the inspirations, at least for me. The other thing as well is, like, I watched Star Wars like in the theater when it first came out. For me, like, just the influence of Star Wars and Star Trek really was very palpable. And that's kind of like one. I mean, I unabashedly, I basically kind of like follow the space career, partly because of all of the influence of Star Trek and Star Wars. I don't normally show my grades, but this is one thing that I wanted to point out as well, is that honestly, math is actually not my cup of tea. I mean, if you look at my grades, I probably should have been in the arts, because that's sort of like where my strengths are. But at the same time, because of that passion about space and wanting to be kind of like in that space, I think because of stubbornness alone and kind of maybe perseverance, that's sort of like what drove me into like a career in space. And essentially in the Philippines, there is no aerospace engineering. And there's only like one university that has astronomy. So I took physics, essentially, even before I knew what physics was, because I knew that was the only path to go. So this was back in 1988 when we first kind of like my first solar eclipse, and it took us 3 days with a bus, a ferry, and a pig pen truck to actually get our 8-inch Cassegrain telescope to watch the first solar eclipse that I have seen. And now I've seen 3, one in Australia and one in the US as well. But again, just because of my focus in space, I did manage to do all of my degrees. I finished my physics degree in the Philippines, did my master's in Canada, and then also did the summer program, the International Space University program, which Eric and I kind of met. And if I trace sort of like my whole path to get to New Zealand, this is it's really 10 hops, where I lived in several continents, including Europe, to kind of like get here. And fast forward like really 30 years, again dating myself, I wouldn't have, like, as a Filipino girl back in the Philippines, I would not have dreamt of what I have done. If I think about like when I was back then and what all of the possibilities for me, which is like, for me, I feel like I'm pretty blessed. And I think that this is not something that is like it's a fluke or a coincidence. I think people can actually be able to like pursue their passion if you think that that's really something that you would want to do. So my first real break, really similarly with Eric, is because I knew these two people as well, with Peter Demandis as one of the founders of the International Space University, and it's not just going to the program. I also was one of the first people on staff, and so when I worked for them, I basically helped create the master's program, space studies program for ISU back in France. And Peter, I mean, arguably, I think what we call now new space, which is really like when I think the private space kind of like ecosystem really started, was really because of his kind of vision of what the space industry is supposed to be, which is not just big government agencies and not just big aerospace companies. And so I think one of the main trigger points to this is the creation of the X Prize Foundation. Do you anybody know about the X Prize Foundation at all? Yeah. So back in 1996, essentially Peter was like saying, well, the space industry is not going much of anywhere. We need to boost it, and we need to catalyze something. And so he made use of the concept of prizes. If you remember, there's a lot of prizes that actually been done in aerospace, and one of these is Lindbergh's kind of like transatlantic flight. And so essentially what he did was he put up a prize of $10 million for the first private company to be able to go up in space and come back in kind of like repeat it in 2 weeks. And that was never been done before, essentially. And because of that as well, it jump-started the suborbital industry. And which is a lot of these companies now are gone, but at the same time there are still, like with Blue Origin and of course Scaled Composites with Spaceship One, who actually won the prize. When they won it, they basically spent about $20 million and 30 engineers. And if you think about $20 million, that's nothing. I mean, that really for the space industry, a blockbuster film is about $100 million. And so you can just like see what prices can catalyze, and that's kind of like one of the reasons why we're using challenges as well here in New Zealand. I'll talk about that later. So the other thing that Peter also started is another company called Space Adventures, and I was just fortunate enough that he invited me to also kind of like help build this startup company way back in 1998. And essentially the goal of Space Adventures is that, while we're still waiting to have all of this real actual space tourism in suborbital flights, well, let's just like start kind of like doing tourism, space tourism type of activities. So from watching the shuttle launch to doing zero gravity flights in Russia and the U.S. to essentially flying MiG flights that go to the edge of space at 80,000 feet, which I can't convert it, so it's like to meters. And so that was a lot of fun because essentially I had to develop a bunch of programs from program development to sales to marketing to operations of it. And so it's like I became kind of like a one-person shop of like trying to get like programs, and so really learning pretty fast on your feet. And so this led to actually the very first private citizen to go up in space. And it was brokered basically by Eric Anderson, who was then the CEO, with the Russians. So if you remember today, the Soyuz the Soyuz spacecraft is the only kind of human-rated spacecraft right now that can actually send the astronauts up to the ISS. It used to be the shuttle but then they retired it. But today it's a monopoly. But the thing with the Soyuz is that at least during those days, they only needed when they rotate people on the ISS, it's only like a rotation of 2 astronauts basically going up and going down. And so they only needed 2 seats, and there's a 3rd seat. And so the 3rd seat was then free to be sold. And so that's kind of like what happened. And so the 3rd seat then was sold to individuals who would want to go up in space. And so this like 7 people, and then actually Simone did it even twice, paid between $20 to $50 million to go up on the ISS. It's pretty expensive, of course, But I always think of it, and I liken this to kind of like the beginning of you know, the the flight industry, or the where in the beginning it's only really, you know, the rich and the well-heeled that are the ones who actually can afford those flights in the beginning of the 19th century. But at the same time, you know, it took only a few kind of like decades where then it became a commodity, and now of course we just take it for granted that we're flying all over the place. So I think it's following that realm. But it also has like perks, of course, being on staff with Space Adventures. I get to do the really fun stuff of doing zero gravity flights as well. So this one's in Russia, which is I favor more because the plane actually has, it's 14 feet up, and so you can really fly like Superman. Here's another one. This is my 30 seconds of fame on Oprah.
I forgot to do the audio on that.
Oh, I don't know if there's any audio.
Well, if you've been looking for a reason to go to Russia, Oprah, this is it. At the Cosmonaut Training Center in Russia, look at this, how fun. You get to float. You travel on a specially outfitted jet that is currently used by the Russian Space Agency to train cosmonauts. Pretty cool.
I mean, that's the only way I'm going to ever be weightless. That is it.
And you can be weightless for 30 seconds. You get 10 weightless rounds for a 2-hour trip. And this is actually how Ron Howard and the cast of Apollo 13 filmed their weightless scenes. Now, this trip might be for you in another respect, Oprah, because it's $5,400 per person. Pretty steep. But
That's worth it to be weightless.
So anyway, that's kind of like the perks of being in a forefront space tourism or organization. So just as an update on where are these space tourism flights now, because like at the moment they don't really have any clients to go up to the ISS because it's being monopolized by all of the actual official cosmonauts and astronauts that have to go to the ISS today. But at the same time, there are now companies. Of course, you probably heard of Blue Origin, which is Jeff Bezos's company they're now looking at potentially the moon, but then they're still working on orbital and suborbital flights. And then, of course, Virgin Galactic just did their successful Spaceship Two flights in the beginning of the year, which they've been waiting for almost 15 years. But it looks like it's finally going to happen. And this year, I think, cross fingers, they think that it will happen. And there are actually New Zealand ticket holders that we know of. I know it's much publicized that Mark Rocket actually has one. He lives here in Christchurch. So, and then there's also other ones that are not just rocket or space planes, but also ones that uses balloons. For example, like Zero to Infinity and Worldview, also alumni of the International Space University. But then, what is really the point of the space tourism kind of like endeavor? And it's really, I think, it's this. It's the point-to-point that we're waiting for. And you know, SpaceX, like basically, is like saying that at least for Elon, he thinks that he's going to fund like his Mars sort of big missions by actually doing this, which would be great. Like if you can go from San Francisco to you know, Auckland or Christchurch in like less than an hour, that would be awesome. The other thing as well is you don't, in terms of space tourism, you also want to have like a destination. So today you only have the ISS plus like the Chinese space station, but in fact Bigelow Aerospace has already launched their beta, like it's not human rated, but they've already launched a bunch of these, like at least 2 of them, like a decade or so ago. And so they're up there. But at the same time, there's now also companies today that used to just be, you know, payloads within like bigger missions, like on ISS or on the shuttle. And now they're also looking at creating this basically laboratories or space hotels using different types of architecture like inflatables. So after 20 years of being kind of like immersed in this, I just thought that like it's actually would be great to actually tell the stories. And so I also got the opportunity of basically co-writing a book with another person like a couple of years back. And that was really fun. Actually, being a space journalist is also another career to think about. I mean, you can have all of those perks, including being able to interview guys like Elon or Anusha Ansari, the first private citizen, or like the pilots of Spaceship One. So it's really great. The thing about this particular project is that my co-writer, I only met him twice in my life. And we worked on the project for 2 years. So I mean, there's like lots of things that can be done, like even in remote places. So then after that, I also worked on this company that Eric was talking about. It was originally called Odyssey Moon, which then became Moon Express, and it was again using the X Prize Foundation with Google launched the Lunar Google Prize, which was not won because they just didn't have the actual teams that got to the moon within the particular time frame. But that was also fun. I was the payload flight manager for Odyssey Moon, and really basically looking at whether clients would have payloads that actually fit the specifications of the actual spacecraft. And then after that, again, along the lines of Peter Demandis, who also started Singularity University. Singularity is an organization that's actually based at NASA Research Park. And what we do is that we actually leverage all of these exponential technologies to solve like big problems in the world, of which actually space is one of them. So there's like 10 of those. Space was one of them. And I had the opportunity of becoming the lead for the space department for a number of years. And basically before I left, I was on the executive management team. I was the chief impact officer. It was great to actually develop programs. The program that I basically worked on was called the Global Solutions Program, and it was really a pre-seed incubator for these kinds of like startups to work on really moonshots. So which is why this is just like an example of how startups that have actually started from Singularity University is now pretty much kind of like on their way to success. Eric talked about Planet. The founders of Planet were faculty and staff back at Singularity. Our students were from Spire, Made in Space. Some of the things that are interesting about this is that, so for example, the co-founder of Spire, it was a banker. The co-founder of Satellogic had no background in space. He was just a polymath. And so they're basically people who are really just coming from different backgrounds, but really interested, and then just moving forward with kind of like what their passion is. You should check out Endurosat. So actually, they have a online. So he's Bulgarian, the co-founder, and they have an online website on basically they can sell you a fully integrated nanosat kind of like in 5 days, and all on the web. But the thing about them as well, or the co-founder, he's also started this nonprofit called why am I blanking? It's like just the Google Space Education Bulgaria, and you'll find it. It's the biggest repository of space aerospace educational videos that you can find, and actually the European Space Agency uses it. So it's something to supplement whatever it is that you're learning here at UC. If there's anything at all that you're kind of like looking for, I think I could bet you'll find it there that's like related to space. So make sure to look at that. So the thing is, as Eric was saying, because of all of these exponential technologies and the thing that it's all getting cheaper, it's faster, it's better. Software is replacing hardware, so the future is really here today. But I really like this quote is that it's here, but it's just not evenly distributed yet. And so you see it in pockets in different areas, which is kind of like the reason why we're here in New Zealand. One of the things that I just wanted to point out as well is that when I came here in New Zealand, I always show the development with these two photos where it used to be you got satellites that are they're as big as sometimes kind of like a room or as big as a refrigerator, and then you're comparing it to now it's been democratized and now we got a shoebox size. But honestly, that's no longer the case as well. This is now the comparison. Today you got pocket satellites that are being created by university students or high school students, actually. And then now comparing it to the chipsat. And basically it's all it's all materially exponentially getting smaller. And what does that mean in kind of like economic terms? It means that if mass is the most expensive part of launching something, if you are now launching just a chip, then it's definitely a lot more cheaper and easier to kind of like do. So going back to like it's not evenly distributed yet. So this is the challenge, at least for us. We think that to actually have a really global space economy, you need to have everybody kind of like involved. But the problem is today, if you look at this, there's the governmental space budgets today is about $62 billion, and it's only 87% is like the 9 kind of like it's the G9s, I guess is what you call them. And then the new space companies also are getting getting better, and there's a lot of them popping up. But at the same time, 70% is also coming from those 9 countries. And then Eric showed you a chart on investments for space startups as well. And that's great, but at the same time, as you can see, most of it is in the U.S. and just that small sliver there is the non-U.S. part. So we need to change this if we really want to create like a real global space economy. And so this is kind of like why we're here. And so we created Space Base. It's a social enterprise. Where at the moment we just put in our application to become an actual charitable company, so to be registered as a charitable company, and so our focus is to basically change this paradigm, and how to do that. So about 2 years ago, Eric and I found out about the Edmund Hillary Fellowship. Which is again kind of like aligned with what we're like thinking about, where the fellowship is asking for basically entrepreneurs and investors to come to New Zealand, create something that is really impactful, that is for New Zealand, and we basically applied, and that's kind of like how we got here. So this is us right now. It's me and Eric here who actually moved here to New Zealand, but we still have another guy, Rich, he's still back in California. He's our blockchain software development kind of like guru guy, and so that's sort of like where we are at the moment. So we're looking at a roadmap essentially, and I always think about this kind of like in three steps, at least from where we are right now. So it's the education bit, the entrepreneurial bit, and then the basic collaboration and community building side. And those are the things that we're essentially working on at the moment. So we're hoping to do outreach and education in different initiatives, and then at the same time we're also focusing on basically birthing entrepreneurs. And entrepreneurs meaning, you know, either you're a student or you're somebody who's just like started a company, but like focusing on space related projects, and then trying to get a collaboration of all of the stakeholders to kind of like help the entrepreneurs actually become successful. The fourth part here is essentially our long-term goal is to make sure that that there is a marketplace kind of like to have those businesses actually show or put up their services and their products. And I'll talk about this in a little bit. The kind of like the mid term goal here is that what we're doing right now is like we're prototyping in New Zealand. We're trying to see if it actually works, what we're trying to do. And then the second part to this is if we are actually successful, then we can also help other countries, specifically developing countries. So as I mentioned in the beginning, like I'm Filipino, I'm still trying to make sure that the Philippines also would have that opportunity at some point. And so we're looking at different, replicating essentially what we would do here in the different countries that do not have like any space industry or space economy. And then the third part is that we want to be more collaborative than competitive, and so we would create all of these communities, but there are also already existing communities that we are friends with, essentially. And so there are communities in the US, in Europe, and if we can create sort of like a protocol that is easily applicable to all, then we can even further combine it. So the other thing that I think is important here is that it's really hard to actually create a community. I mean, we've been here for 2 years. I think we've done quite a bit, but it is hard. I mean, creating collaboration is not an easy kind of thing. So one thing that we want to leverage really is creating essentially tokenized credits for content creation, or basically for people who want to help. Then we would like to award sort of like tokens that potentially can be used in the greater community and collaboration platform kind of in the future. The other thing is that, like I mentioned about the marketplace. So yeah, it's right now there is no, for a lack of a better analogy, there is no kayak of space. So like today, you can go, if you want to go somewhere, you can either use a big company like Air New Zealand, or United Airways or AA or something, but you can also use the small companies like Jetstar, or like in the US Southwest or whatever, but it's all like all in the same level playing field. So what we want to create at some point in time is a marketplace where anybody who has either services or products, regardless of whether you're in New Zealand, you're in India, or you're in the US, that you have the platform or the opportunity to actually compete in that sort of like in that global atmosphere. Why New Zealand? This is one question that we've always been asked, and we actually do think that it is the perfect place to prototype, and there's a lot of reasons for this, and kind of like I've outlined here. It's essentially there's a lot of things, from having a progressive government, that actually acts quickly. I mean, just compared to where we came from in the U.S., I mean, we just the bureaucracy, to having already the launch and infrastructure in place. I mean, Rocket Lab being here really makes it a lot more easier, I think, in the short and the long term. You've got already basically a technical, educational, and then entrepreneurial ecosystem, so that's in place. And then also the location itself. Actually, the isolation of New Zealand for launches is great. If you were launching from Cape Canaveral, you'd always be thinking about the air traffic and all of the problems that come with very kind of like dense kind of like air traffic. Well, here there's nothing. You can have more launch angles, and there's nothing in the south. There's nothing in the east, and so it's really good. The other thing as well is like most people, when we first came here, even with the government, we were saying we were going to look for all of these organizations and companies that are already working in some form or fashion on space, and they were saying, what? Well, they won't have Rocket Lab, but actually that's not true. Although a lot of those 200 plus organizations are outreach and education, there are companies already that you wouldn't know are actually supplying a lot of the big kind of like aerospace companies elsewhere, and then you just don't know them. The other thing as well that's, as I was like saying, it's very hard to kind of really create collaboration. The New Zealand space ecosystem exists. Like there's, from government to academia, and then there's already like industries, but they're all on silos. So it's like right now they're all not interoperating together. So we're like trying to figure out how can you actually leverage all of those. So our progress so far, as I mentioned, like, those pillars that I was talking about earlier. So right now, we've done quite a number of briefings and presentations. We created a meetup group in Wellington. We're collaborating with potentially with Space Place or other organizations like the Marchand Trust for more outreach. We started the New Zealand Space Challenge last year, and this year we're basically partnering and the delivery partner for the New Zealand Aerospace Challenge. And then for tools and training as well, we have been mentoring already space startup companies in New Zealand. And we also, as part of the challenge last year, we did some training. And also with the New Zealand Aerospace Challenge this year, we're kind of like debuting the very first virtual aerospace incubator. So that's the other thing that we're really excited about today. On the collaboration portal on spacebase.co, we are on beta in terms of the directory and the calendar. The thing that we're working on right now is essentially a directory of all of space projects, of which the New Zealand Aerospace Challenge is going to be the first one, and the teams that are going to be in that incubator. And then essentially we're still on the design phase for that marketplace that I kind of like talked about. This is just, again, what are the outcomes for the New Zealand Aerospace Challenge last year? Essentially, we had like over 30 plus partners and 13 economic development organizations that were helping us during that time frame. There was about 20 potential solutions that came out. Last year was more extreme environments. And then we're still following the startup that came out of it. So the winner last year actually did go to Antarctica to test their solution, which was great. So this year we're working on the Aerospace Challenge with the 7 partners included Airbus and MB and Zira, and now it's focused on sustainable agriculture. And actually, the incubator application just closed like 25 minutes ago. So I'm going to be looking at hopefully a bunch of really good proposals. So this is I'm almost done. So so this is like my slide on like how can potentially you help. So again, as you can see, there's only 3 of us, and we do have we hired a software developer company in Wellington to actually work on our collaboration platform. But at the same time, yeah, we are a I guess what you could say is that we're a philanthropic organization. And we definitely need more help from people. And this is kind of like, I think, the 3 things that we're working on at the moment. For community building, we definitely need help to kind of like beef up the collaboration platform by either its content, with blogs and also helping with the wiki as well. Next month, we're actually open sourcing the software. And so in terms of the software development, actually, we are at the stage where we need to fundraise for the next phase of development. And so we're also looking at volunteers who actually can do Drupal, if you know of anybody. There's a lot of features that we're still working on, especially the next one is the contribution credits. What we're trying to do right now is that anybody who would help us, we would at least assign contribution credits so that at some point in time, those credits can actually be either leveraged for either voting rights or credits for things that you can do on the platform as well. So this is really my last slide. The best way to predict the future is to basically create it yourself. And again, as I was saying when I first started this, my career is very much unconventional. I mean, I started from physics and space science with a technical background, but it was, I'm more of a kind of like an operations person, and actually business and management is something that I really like looking at and basically catalyzing. So if that's like something that you're kind of like interested as well, as opposed to being to doing technical stuff, then there are pathways to be part of the industry, to kind of like go work on any particular area that you would want to do. Thank you. Any questions? Yeah.
You mentioned that a lot of private groups are going into satellite launching, for example, like university students and even high schools. Where do they get their funding? Is it supported by the school they're from, or are they appealing to private organizations like businesses? Like where exactly?
Yeah, that's really interesting. And there's, I don't think that there's a straightforward answer.
Repeat the question.
So yeah, where do organizations who are, or universities or organizations who are actually developing like satellites or space projects, where do they get their funding? I think there's many areas. Well, definitely in university, there are some where you could potentially use, you can leverage the university resources as part of programs to do that. But at the same time, there are many ways of also fundraising for projects. There's, for example, there's another online organization in the U.S. that only kind of like puts not just space, but science and space projects and fundraising for those. And so it's like more like a crowdfunding type of way of funding. So yeah, I don't have a straight answer at the top of my head. Eric, if you want to add more, but there are grants as well that can be had like in different places, and then also there are philanthropic organizations as well that do that.
There's, sometimes a lot of these things are done with sponsorship, and there's one thing, this balloon flight actually, somebody realized that you could actually put up a little display and flick through maybe 200 kind of images and take a picture with the Earth in the background. And so there was actually money raised by sponsorship of what images were being shown on these, besides all the 120 students that were at the program. We did that. It's a lot of it's creative leveraging of sponsorship and things like that, and a big part of it that makes these things possible is that the prices come way
It's
down,
gotten- yeah.
and there are interesting possibilities. Like Peter Beck has
Yeah,
said
that's the other thing.
that he wants to increase the rate of the Rocket Lab launches, and he would like to start having New Zealand built satellites on almost every launch, and so there may be coming up every month flight opportunity. So it's,
Yeah, and that's really a unique opportunity because Rocket Lab is here. And then again, thinking about satellites where you can now create pocket sats and like chipsats, then that's like almost a really, it's no burden for them to kind of add those in like a regular
yeah,
payload.
it's kind of crazy that one little dispenser like this last month dispensed 30 chipsats, popping out, and so it's
Yeah.
A question. Why did you choose Drupal?
Why did we choose
why do we
Drupal?
choose Drupal?
Oh yeah, well,
that's a rich
yeah,
question.
that's probably a rich question because I mean, he did actually look at different elements, and because we were developing it, like we were customizing it, so it wasn't just like, and plus the fact that he's looking at the kind of like the long-term things, and I think some of the features and the elements of what he wanted to do, especially this is going to go on blockchain at some point as well. That, yeah, he at least in his mind right now that's the platform to use. Yeah.
One thing, I might put up my last slide because I wanted to point out that there's a bit.ly address for where our slides are kept.
Also, do you, if you don't mind me asking, where do you conduct your QGIS?
Oh, okay. Yeah, we for last year we did it in several locations in Lower Hutt and Auckland and
Actually, one was in Christchurch.
one was in Christchurch.
So we did that for the challenge last year, but actually the videos are online, so you can actually go on the Space-Based website and you can find it somewhere in there.
Somewhere. Yeah, I just wanted to point out
This
the
one.
bit.ly address is where our slides are kept.
Awesome. Well, thank you so much for doing this talk. I personally found that really amazing. I'm pretty sure everyone else did as well. So we have a couple of tokens of our
that's very nice.
presentation. Yeah, one of our members actually designed
Oh, look at
this
that.
card. It's
Wow.
pretty cool.
Hand drawn.
And,
Oh, this is
Oh,
wonderful.
so cute.
Yeah.
we're trying to do a bit of a line of merch as well. So.
You got
Yeah,
branded
the
logo.
branded
Oh, that's
logo,
great.
right? So,
This is really cool.
yeah, awesome. Thank you very much. And we think what you're doing is amazing. So anything that we can do to help, we would love to do that as well. And because we agree that making a community in New Zealand, or in space and for the space industry, is one of the best things that we can do, especially internationally as well. So.
Oh, that's great. Yeah, well, we're really excited that you've formed a student group here, and that gives us a lot of hope for the future. That's good.
Well,
Oh, thank you. Thank you.
Thanks.